Hello there. Welcome back. In this video, we are looking at page 101 in the exercise book. This is for lesson 6.2. And there are, bear with me a second, looks like there are 19 questions in this lesson. Sorry. I think I'm about to sneeze. No, maybe not. There are 19 questions in this lesson, and these are reviewing the textbook, chapter 6, lesson 2. So I'm going to be doing most of these, I'd say, in my notebook. But here's the first question. It says to consider the following linear function. Which statement is true? The common consecutive difference is more than 1. The common consecutive difference is 25 hundredths. The first consecutive differences are not constant. The common consecutive difference is negative, or the common consecutive difference is equivalent to the y-intercept. Well, let me go ahead and identify the y-intercept. That is going to be this number right here, because this is in slope-intercept form. So the y-intercept is positive 4. So the only way I'm going to be able to answer this question, you guessed it, is to draw out the common consecutive differences table. So let me build one of those right here. And you can build it with me if you would like to. You just want to draw a table. And remember, actually I've already messed it up, but that's okay. I'll just leave it here. Remember, we need to start this table with some x's and y's. So let's draw a table for that. I'm also going to use a few of the other labels that we've learned just to review those. So let's give it plenty of space. That should be enough. So when we first started working on these way back in another chapter, we called them x's and y's. And we learned that x's are the input values and that y's are the output values. And then we learned a new way of writing function notation. And we learned the terms domain and range. And then with respect to graphing, we learned that this is the independent variable and this is the dependent variable. So all of those things mean the same thing. Okay, so I'm going to pick some points. I think I'll use -1, 0, 1, and 2. And then let's make some space for the actual function that we're going to need. And I'll do that right about here. Let's leave plenty of room to do the math. And that'll go across here. And so I'm going to write my function in there. It is f of x equals 1/4 of x, add 4. So that's the function that we are going to be working with. So I'm going to zoom in right here and let's do some math. So we're going to say when x is -1, I will have 1/4 times -1 plus 4. And that will equal -0.25 plus 4. And that will equal 3.75 positive. So when x is -1, I don't even have to do the math on this one. I can tell you that it will be the y-intercept because x is 0, but I will do the math just for practice. So when x is 0, y will be 0 plus 4, which is 0. Excuse me. I told you I can't add and subtract in my head. It's 4. Then when x is positive 1, we're going to get 1/4 of positive 1 plus 4 is, that's 0.25 plus 4 is 4.25. And then finally, when x is 2, we have 1/4 of 2 plus 4. That is 1/2 plus 4, or 4.5. So here are the values of the table. And I first want to test to be sure I'm dealing with a function. That's always a good idea. Remember, with this one, the x's cannot be duplicated, and they're not. So this is truly a function. And then we can tell if it's 1-to-1 by looking at our y values. Again, I don't have to do this. I'm just reviewing with you every chance we get here. These are all different, so this is a 1-to-1 function. All right. So I could put that up here. This is a 1-to-1. I can also tell you that this is linear because the x is to the power of 1, and it's therefore is linear. And that really would help us solve, or at least eliminate, some of our answers. But let me go ahead and do the math, and then we'll worry about the answers. So we are ready to start calculating our consecutive differences. So I'm going to make a space to do that right here. And I can tell you, well, I won't tell you. Let's just see. But I suspect I won't use that last section over there. So here is the first. Level of consecutive differences. Now remember what consecutive means. Not only do our x's have to be different, they have to be consecutive. They have to be in order without skipping anything. And they are, but I should have checked that to start with. Okay, remember how this works. You will bring this value up here. So we have 4 minus 3.75, and that is going to be 0.25. And then we have this value, 4.25 minus 4. I'm liking what I see so far. If it checks out one more time here, I'll be a happy lady. So 4.5 minus 4.25, and sure enough, it is common at the first level. So we can say that it is a common difference here at the first level. We're done. Once you get commonality, you do not have to keep going. If you do, you will get 0 in the second level. But we've got what we need here. So the first consecutive difference is 0.25. So let me rephrase that. The first common consecutive difference is 0.25. That's what we're looking for. It needs to be common to be the answer we need. Okay, so A is clearly not true. The common consecutive difference is more than 1. Well, that is not true if 0.25 is the common consecutive difference. That's less than 1. The first consecutive differences are not common. That's a false statement. The common consecutive difference is negative. That's a false statement. The common consecutive difference is equivalent to the y-intercept. Well, 0.25 does not equal 4. So that also is a false statement. So this is truly a linear function, as we suspected it would be. Alrighty, number 2. Let me crop this down. I am going to try to just film 1 page per video. If some of these get excessively long, I won't be able to do that, but we'll see. All right, what is the common consecutive difference for the quadratic function? So on this one, I know that I'll have to go 2 levels to get my common consecutive difference. So let's draw a table. I won't use red. And I'm not going to go through all those labels again. We'll just use a few of them, a couple maybe. Guys, I just had the best calzone from the Walmart deli. I couldn't believe how good it was to be store-bought in a package. And it was cheap. It was just really, really good. I'll probably be up all night with heartburn. But okay, x's and y's. Let's do f of x as well. So we have x and y. And then, of course, x doesn't change, but y is also known as f of x. And the function in question is quadratic, according to what they're telling me. So I need to make room for the math, first of all. I'm going to leave quite a bit of room here. Let's do, here will be our second consecutive differences. And this is the column where I expect the good things to happen. But we'll see. And then here we're going to put our function, which is f of x equals 2x squared plus 1. So it looks quadratic. It's to the second power. But we will prove that if it is indeed quadratic. So I'm going to pick 5 consecutive x's. I'm going to use -2, -1, 0, 1, and 2. Those are the 5 smallest numbers that I can pick that are both negative values and positive values. And then here we will have the first consecutive difference. And they're consecutive because of the 5 numbers I just chose. And then here we will have the second consecutive difference. And this is where I expect commonality. But we'll see. All right, so here we go with the math. Well, first of all, let's check to see if we have a function. We chose 5 different values for x, so it is a function. And I'll tell you in just a minute if it is 1-to-1. Since it's quadratic, it may not be. It shouldn't be, because remember, quadratics give us a parabola. All right, so here we go with an x of -2. And so we have 2 times -2 squared plus 1. That's going to be 2 times +4 plus 1. So 8 plus 1 is 9. Then we have an x of -1. So we have 2 times -1 squared plus 1. So that's going to be 2 times +1 plus 1. So that would be 2 plus 1, which is +3. Then f of 0, this will be the y-intercept, where 0 is your x term. So 2 times nothing plus 1 is nothing, plus 1 is 1. So the y-intercept is at 0, positive 1. I could have told you that because of this value of c right there, baby c. All right, f of 1 is going to be 2 times positive 1 squared plus 1. So 2 times 1 plus 1 is 2 plus 1, or 3. So this is not, it is a function, but it is not 1-to-1, because right there, those y values are duplicated. And I suspect that's going to happen right here as well. 2 times 2 to the second power plus 1. 2 times 4 plus 1 is 8 plus 1, which is 9. So this is not 1-to-1 because we have duplicates. There's a set, and then here's a set. But remember, to get that parabola shape, you want duplicates, because that's the way that you get the duplicates. The parabola has to come down and then make a turn back up. And the way to do that is to get the same values on both sides of that parabola. And let me not delete that. And you might be saying, well, how do you know, Miss Amanda, that it opens upward? How do we know that? How do I know that this parabola doesn't look like this? Whoa, sorry. That it's not upside down. And the way you know that, I need to adjust him just a hair. Normally I wouldn't be so finicky, but this is important that it's right. It needs to look right. So here is the parabola. I know it turns upwards, that it makes the bowl shape, because my x squared term is positive. So I told you that this is the y-intercept, and that proves true right here. If that 2, the coefficient in front of the x squared, is positive, you will get a parabola that opens to the sun. Okay, so let's find consecutive differences. Again, this tells me that it is not 1-to-1, but that's okay. We don't want it to be. If it's quadratic, that wouldn't work out very well. The yellow tells me that it's a function. Now, here come the consecutive differences. So I'm going to take this value, which is 3, minus 9 is negative 6. Then 1 minus 3 is negative 2. Then 3 minus 1 is positive 2. And then 9 minus 3 is positive 6. So we can say that there is no commonality at the first level. But we knew that, because at the first level it would be linear. So let's try the second level. So I'm bringing this negative 2 right here, and I'm subtracting a negative 6. So that's a difference of positive 4. Now put that in your calculator if you need to. Then 2 minus negative 2 is positive 4. And then 6 minus 2 is positive 4. So here we get the common consecutive difference. At the second level, that proves that this is a quadratic function. Okay, so let's look at our choices. What is the common consecutive difference? In other words, what is the number that is true every time? Well, we have 4, 4, 4. So the common consecutive difference is 4. Okay, let's get one more. Again, you are welcome to print these if you want to print them. You can also ask your instructor to print them for you if they have the ability to. I'm sure they will. Some of our programs do not have the ability to print. But you are welcome to print my notebook. You have permission from me to print my work in the notebook. All right. John is joining a golf club that has an annual fee of $1,000. That's pretty steep. And charges $15 per round of golf. Which table represents this situation? Well, I'm going to set up an equation, first of all. So the cost is the price per round times the number of rounds plus the fee. And the fee is $1,000. So if you go to this golf club and you pay your $1,000 and you never play a game, you still owe them the $1,000. That's the y-intercept, guys. That's telling me that 0 games, you still owe $1,000. And right there, I can tell you the answer almost. It has to be B or E. But let's work it the way we're supposed to. If I were on a test and I had to guess between B and E, I would look carefully at those, and then I would make my guess. All right, so Y is the cost. The price per round is 15, and X is the number of rounds. If you write this in function form, you're going to have f of x equals 15 times x plus 1,000. That is the function for this story. Now, if you know that baby B is 1,000, you know baby B is a y value. So let's take a look here. What this is saying to me is that 0 games, you still owe $1,000. So A says 0 games, $0. That's not what we're looking at here. So I'm just going to mark off option A. That's not it. B says 0 rounds or 0 games, $1,000 fee. That's true. C says 0 games, a $985 fee. That's not what our story says. D says 0 games, $0. And E says 0 games, $1,000 fee. So it's B as in boy or E as in elephant. We know that is true because of that y-intercept. See why I want you to know what that means. When I say y-intercept, that is very helpful for me to know because I eliminated 3 answers right there. Even if I had to guess at this point, I've got a 50-50 shot instead of a 20% shot of guessing the right answer. So use those strategies and it will help. But we don't have to guess. I'm going to put in this value for x and y. So I'm going to put this in for x and that bottom one in for y and see if the equation proves to be true. So when f of x is used to predict 1x, that would be 15 times 1 plus 1,000. That is saying that the output is 15 plus 1,000 or $1,015. So is that what we have here? This is saying if you play 1 game, it will cost you this amount. This is saying one game costs $985. That's not it. But look at this one. Because we've already figured one game. We don't have to do it again. That's the one I'm looking for. Because you pay the $15 for the game, but you also have to pay that $1,000 fee. So I think I would go with E, and I think I will spend my $1,000 buying calzones at Walmart. I'm not a golfer. So any of you out there who are, maybe you can tell me if this is reasonable, but not for me. All right, let's go back to the homework page and put the answers on here. The first one was B, as in boy. Then C, as in cat. And then finally E, as in elephant, for page 101. And I will see you for page 102 in the next video.